So today we started talking about area problems, okay, and using these with quadratics. So basically, it's not your normal area problem. We're still using your formula that you've learned forever ago about area, which you remember is just basically length times width, okay, and it doesn't matter for these, y'all, necessarily which one you deem the length versus the width. Just know that if it asks for a specific one, make sure you identify your variables and so forth about that, okay? All right, so first thing, given the diagram for the first problem, given the diagram below, find the value of x in the area of the if the area of the rectangle is 78 square meters. So again, we're going to do length times width. I usually make this long side my length and then this little shorter side my width, but whenever I write this out, a lot of times it's just prettier if I put the x in front times x plus 7, okay? And now it says if the area of the rectangle is, remember for us, is means equals, and then 78. Okay, so we're going to do what we normally do on the left-hand side. We're going to distribute, which is going to give me x squared plus 7x, okay? And we always want quadratics equal to 0. That is very important, okay? So to do that, we're going to move that 78 over to the left, okay? And it's going to be x squared plus 7x minus 78 equals 0. All right, so now you're trying to think of the factors of 78, okay, that can add to give me um, 7 and then multiply to give me 78, okay? So, sorry, my blue pen was not cooperating with me, so let me grab another one. All right, so what we've got here is whenever we Xbox this, which is basically what we're going to be doing, okay, just like normal, you would have your negative 78 at the top and you would have your 7 at the bottom, okay? Okay. All right, so now we're trying to find two numbers that multiply to give me 78 that add to give me 7. And we talked about this in class. Like, you kind of just want to start with something like that you're familiar with. Like, for instance, we know that 78 is divisible by 2. So 2 times, and you just try to figure out what that could be. It'd be 2 times 39. Okay, well, we could do 3. It's going to be 3 times 26. 4 doesn't work. 5. Okay, you can keep going, all right, until you get down to 6 times 13. And that's what we're going to use is 6 and 13. So I'm going to have a 6 on one side, a 13 on the other. If I need a positive 7, then I'm going to need a negative 6. Okay, so that takes us to here. X minus 6 and x plus 13 is equal to 0. So then whenever we drop our factors out and solve, we get 6 and negative 13. So since we're talking about area, y'all, your answer can never be negative. So we are going to throw out the negative 13 and we're going to use the 6 only. And it does only ask for the value of x. So our answer for this problem is 6. Okay, now if it asks for the dimensions, we'd have to plug in or anything of that nature. And you're going to see, and this is what I talked about, that almost every problem asks us something different. So you've got to make sure you're reading and paying attention to what is being asked within the problem. Okay. All right, moving to number 2. Same thing. We're going to do the area. So I'm going to do x times x minus 3, and that's going to be equal to 108. So x squared minus 3x equals 108. And when I move that over, I've got x squared minus 3x minus 108 is equal to 0. Again, take your time. Some of y'all got these pretty quick in class as far as what the numbers were. So yeah, this one is in fact 12 and 9. If it's a negative 3, it's going to be a negative 12. So x minus 12, x plus 9. And so when we drop these out, our answers are 12 and negative 9. Throw out the negative because again, what's length? And they wanted to know the actual dimensions. So x is one of our dimensions. It's right here. So our, what I call our length is x is going to be 12. Okay. And then the other one, you're going to have to plug in the 12, and 12 minus 3 gives me 9. So my dimensions are 12 and 9. Okay. All right. Same thing. Find on number 3. Find the dimensions of the rectangle below if the area is 128. Okay. So this time we've got binomials. Okay. So it's going to be x plus 7 times x minus 1, and that's going to equal the 128. Okay. So remember, we can simplify all this out. Y'all should be familiar with distributing and what that entails. Let me change my brightness real quick, y'all. Hold on. All right, so I'll walk through this one just to make you aware. X times x is x squared minus 1x plus 7x minus 7. Okay, so all that combined, and then I'm going to go ahead and move that 128 over. So x squared plus 6x, and then negative 7 minus 128 more is minus 135. So that's what we're x-boxing with negative 135 and 6. Again, I gave you some time to think about that in class, but it is going to be 15 and 9. Positive 6 means we need a negative 9, so we've got x plus 15 and x minus 9. And when you drop those out, it gives you negative 15 and positive 9. Throw away the negative. Wants both the dimensions. Okay, so that means that 9 has to get plugged in for our x. So 9 minus 1 and 9 plus 7. 9 minus 1 is going to give me 8. And 9 plus 7 is going to give me 16. So our dimensions are 8 and 16. All right, so now the first 3 that we had talked about this too, that the rectangle was drawn. Please do get in the habit of drawing whatever figure it is we're talking about, y'all, because sometimes it's just better for y'all to see that labeled correctly with the figure, okay? So I'm going to draw me a little rectangle. Doesn't have to be anything fancy. One side's going to be x plus 3, and the other side's going to be x minus 8. So we're going to start regular. Area is 60. So x plus 3, x minus 8 equals 60. Distributive property gives me x squared, and then I've got minus 8x and plus 3x, which gives me minus 5x minus 24 equals 60. Rearrange that, which means to pull that 60 over and subtract it. And now we can Xbox with negative 84 and negative 5. Okay, so you're trying to think of 2 numbers that multiply to give you 84 and add to give you negative 5. Okay, and again, y'all are pretty quick on these. It was 12 and 7. With a negative 5, it's going to be a negative 12. Okay, so drop out your answers. So that's a positive 12 and a negative 7. Throw away the negative. So 12 is our x, and it just found the value of x, so x is in fact 12. So this is an application of your problems that we've been doing, more so than just giving you the problem and telling you to factor and so forth. This is the actual application through word problems of those quadratics, okay? All right, find the length of a rectangular garden. So again, I'm going to draw me a rectangle. The length of the rectangular garden is 4 meters more than its width. And remember, whatever comes after the than is our x. So I'm going to make my width x, and then 4 meters more than that is going to give me x plus 4. So again, area is length times width, and it equals 60. I'm going to move that 60 over and set it equal to 0 just to save me a little bit of room. So y'all are factoring negative 60 and positive 4. All right, so we're going to go with 6 and 10. So it's going to be a negative 6. So we've got x minus 6 and x plus 10, which dropped out gives me 6 and negative 10, throwing out that negative. But it wants you to find the dimensions. So 6 is our x, so our width would be 6, and then our length is going to be 6 plus 4, which is 10, or 6 and 10. Okay. All right, number 6, the length of a rectangle is 6 meters less than its width. So the width again is our x, and then x minus 6. That's equal to 27. So let's just, in our mind, skip a few steps. That's x squared minus 6x. Bring that 27 over, making it minus 27. So now we can x box. Negative 27 on the top, negative 6 on the bottom, 9 and 3 with the negative being on the 9. So that gives me 9 and negative 3. Throw out that negative. So 9 is our x. And again, it wants both of the dimensions. So one of them is 9. And then 9 minus 6 is 3. Okay. All right, so get a little bit more difficult. All right, a square is altered. All right, so square, first of all, it's our main thing. So we're going to draw us a square. Remember, square has all sides are the same, and we don't know those sides, so I'm going to make them both x. So that one dimension is increased by 5. So I need to add 5 to one side, and the other one is decreased by 2. So I need to subtract 2. So we're still doing area, x plus 5, x minus 2. And the area of the resulting rectangle, and it's a rectangle now because the sides aren't the same, okay, is 98. All right, so that's x squared minus 2x plus 5x minus 10 equals 98. Just going to work this one all the way out just to make sure everybody's with me. So that's x squared plus 3x minus 10, and then I'm going to pull that 98 over, so we're equal to 0. Okay, so now you are x boxing with negative 108 and 3. And I'm pretty sure, again, we're going to go with 12 and 9. It's going to be a negative 9 because it's a positive 3. So x plus 12, x minus 9. So I'll drop them out. That's a negative 12 and a positive 9, throwing away that negative. All right, so one of our sides is 9. Now, it says the area of the resulting rectangle, but it wants you to find the area of the original square. So if I go back to my original square, remember both sides were the same. They were just x. So if x is 9, then it would be 9 times 9, which is 81 for my original square. Okay. All right, and then number 8 is the one like to the left there, okay, where we are doing the area of a shaded region. Now we've talked about area of a shaded region in terms of just combining like terms. We've not done it where we actually had to calculate it first, but the good thing is you have seen the shaded region, so we kind of know what to do. All right, so the first thing we need to do is we need to find the area of the big rectangle, which includes the gray and the white area. Okay, so that's going to be 2x minus 1 times x plus 6. So if I multiply that out, that's 2x squared plus 12x minus 1x minus 6, or 2x squared plus 11x minus 6. So that's the whole rectangle. Then the area of just the white part is going to be x and x plus 3, which gives me x squared plus 3x. Okay, and then in order to get just the shaded part, remember we did need to subtract these. So that's 2x squared plus 11x minus 6 minus x squared minus 3x. And we're going to combine like terms. So 2x squared minus x squared is 1x squared. 11x minus 3x is 8x. And the minus 6 just comes down. But reading the problem, it says the area of the shaded region, which is now what we found, is 59. So I need to move that 59 over and subtract it, which gave me a negative 65. And here's what we're Xboxing. Okay, so we're going to Xbox with, where to put it, 65 and 8. Okay, oops. Okay, and that's going to be 13 and negative 5. So negative 13, positive 5, throw out the negative. Okay, so 5 is our X, and it wants to know the dimensions of the outside rectangle. Okay, well, that's these two right here. All right, so if X is 5, we're going to do 2 times 5 minus 1, which is 9. And then we're going to do, we'll run out of room, X plus 6, so 9 plus 6, which is 15. So 9 and 15 were our two sides there. Oh, sorry, y'all, it's 5, not 9. I was looking here. So it's 5 plus 6, which is 11. My bad. Looked at the wrong place. So that's an 11. It's 9 and 11. Okay. All right, now, bottom 4, consecutive integer problems. So in first semester, we talked about consecutive integer problems. We talked about your symbols for consecutive integers. And most of y'all really kind of understood exactly what we were talking about. So that means in a row. So remember, if it's just consecutive, all right, it is x, x plus 1, x plus 2, and it's however far you need to go. But if it's even or odd, we have to skip. Okay, so that's important. All right, remember, a couple of y'all couldn't tell me today, product means multiply. 2 positive consecutive integers, so it just says consecutive. So we're going to use x and x plus 1. Product means to multiply is 56. Y'all, this goes back straight to the beginning, okay? X squared plus x, set it equal to 0, and now we're going to factor. Now, sometimes y'all can do some of these in your head. Like you can tell me two numbers that multiply to give me 56. Okay, so it's 7 is the first one, and then 7 plus 1 is the second one, which would be 8. All right. The product of two positive consecutive even. So since we're consecutive even this time, we've got to skip. So product again is equal to 80. So set it equal to 0. And Xbox with negative 80 and 2. And again, we're at 10 and 8. 8's going to be negative. Throw out that one. So one of them is 8. And the next one after 8 is 10 because they are consecutive even. Okay, so 2 more of these. Might be a good time for y'all to stop and look. Try them on your own. Okay. 2 positive consecutive odd. So again, consecutive odd where it's x and x plus 2. All right, the square of the first. So that means you take the first one and square it, added to 3 times the second. Y'all, if you don't put that in parentheses, you're wrong. Okay, make sure it's 3 times the whole thing, and this is the whole thing is the second one, is 24. Okay, so we're going to simplify from here. Now, again, we'll work this out. So we're going to move that 24 over. So we've got x squared plus 3x minus 18 is 0. Let's Xbox there with negative 18 and positive 3. So 6 and negative 3. And again, y'all, it kind of helps you. It said consecutive odd. 6, even though it's also not positive, because it does say positive, but it's also not odd. Okay, so we're throwing that one out. So it's going to be 3, and the next one after 3 is 5. All right, last one. Oh, this time it's 3 positive consecutive integers. So that's going to be x, x plus 1, and x plus 2. Such that, here we go. The product of the second and third. Second and third. So x plus 1 times x plus 2 is 72. Okay, and we want it set equal to 0. So again, we're moving that 72 over. And you're gonna Xbox. Y'all, we should be so great at factoring and our multiplication by now. We have done so many of these problems in the last 2 weeks. So negative 10 and 7 again. Can't be negative, so it's 7, and it's just consecutive, so it's 7, 8, and 9. Okay. All right, worksheet 13 is your homework tonight. I believe the odd problems were the ones that I asked you to do. Make sure you draw your figures. Make sure you work everything out. We did talk about Desmos with these in class. I will show you that in class. I'm not going to show you that on the video. So just be mindful of that. You will have, I can show you that tomorrow as well in class.